This is going to be the 8th grade Unit 6 test review. So taking a look at number 1. It says the graph below displays water levels in hours. Based on the given graph, explain the slope of the line in terms of unit rate of the water level in feet per hour. So we're just trying to figure out how many feet per hour this thing's going down. My goal is just to read the graph and figure this out. So here's what I'm going to do. We're talking about our answer. We're talking about in feet, and we're talking about in hours here. So we want to figure out how many hours we went down. How many feet we went down in 1 hour. So let's look at hour 0. At hour 0, we're at 14 feet. Let me change color so this shows up a little bit better. We're at 14 feet at hour 0. Well, after 1 hour, we are down here at 12. So we went from 14 down to 12. So we went down 2 feet in 1 hour. So that's 2 feet per hour. I mean, it's about as straightforward as we can get it. Just to show you that that's the way it's going to work, because I could do this with any hour on here. I didn't have to start with 0 and 1. Unfortunately, this graph is terrible to read. We're going to try to read that one right there. So at hour 4, we're at 6 feet. So after 1 hour, so we went from hour 4 to hour 5, we're at 4 feet. Well, from 6 to 4, we still went down 2. So we are definitely talking about going down 2 feet per hour. So now we're going to figure out what answer choice says that. Rarely is the answer not here. I'm always leery on those. It happens, but it's very rare. So B says the slope is -1. Well, we just said it's -2, so B is out. C, the water level declines 2 feet each hour, so the slope of the line is -2. That is exactly what we just said. I'm going to put a check by that because I want to double check D just in case. D says in 1 hour, the water level declines 2 feet, so the slope of the line is -1/2. Well, that doesn't make sense. It wouldn't be 2 feet and then all of a sudden -1/2. So our answer is definitely going to be C on this one. Like I said, just by reading the graph. There are other ways to do it. I do want to mention that you can always do change of Y over change of X. That would have absolutely worked. In fact, actually, that's really what we did. We looked at how many feet it changed over 1 hour, and that's our change of Y over our change of X. We just kind of reasoned our way through it instead. Now take a look at number 2. It says the following table displays the number of dollars Y in X hours. Which equation can be used to determine the number of dollars Y in X hours? Okay, just looking at the answer choices, some of these don't even make sense. Our equations never begin with X equals something, so D is out. Our equation could look like that. I'm not going to worry about that one yet. Let's just take a look at this. Let's look at, I see a Y and I see an X, so here's what we are going to do. I'm going to change this to red. We're going to do change of Y over the change of X. And sorry that my pen is so darn clicky on this iPad. So change of Y, I'm going to look at, so we went from $7.82 to $15.64. Well, that change is $7.82. So pretty much what I'm doing is I'm adding $7.82 every time. Well, my change of X, we only changed by 1 hour. So if I'm filling this whole thing out, and I will, $7.82, and we're talking about that every 1 hour. Well, if I divide these two, it's just 782. So that's our slope, or our M. So if this is M, I'm trying to figure out how much I want to tell you guys, because at this point, you guys ought to know the M, slope, change of Y over change of X, rate of change, constant rate, all of that stuff that we've been talking about, which feels like what feels like from the beginning of the year, are all the same dang thing. So here's your quick reminder. Y equals mx plus b is what we use for pretty much every set of equations. We just found M. And this is what's called a proportional situation, which means that there won't be a b. So my equation would be y equals that m that we just found, that 7.82, and then our x would come at the end. So the only equation that matches that is b, which is the only one that really looks like anything we've talked about this year. C was kind of questionable, but I'm telling you, this is a proportional situation. It's not going to have a plus anything at the end. And what you can always do, if you are not sure, a fail-safe way to check these is for example, I could take this 3, and I could plug it in here for x, that x right there. If I did 782 times 3, I would get that 2346 over there. If I took this 4 and I plugged it in here for x, I could do 782 times 4, and I would get this 3128. One more example just to be on the safe side. If I took this 2 right here and I plugged it in here for x, I could do 7.82 times 2 and I would get 1584. That is the quickest way to check these out when you are not sure. Number 3. Nicole works at a corner bakery and can produce 20 pastries in 2.5 hours. Which of the following represents Nicole's rate of production? Well, so she's doing 20 pastries in 2.5 hours. I think I would rather know how many she can do per hour. Unfortunately, well, yeah, I'm going to go ahead and do that. We're going to do 20 pastries per hour. So I'm talking about pastries, paste, I guess that should have an E on it, whatever, per hour. So what I'm going to do is I'm going to take that 20 and I'm going to divide it by that 2.5 or 2.5. So I'm going to do 20 divided by 2.5. That tells me that she's going to get 8 done every hour. So she's doing 8 per hour. She's making 8 pastries every hour. So I'm going to come over here looking at answer choice A. Well, if I was writing an equation, it'd be y equals 8x, not 10x. So A is out. Right here, I'm going to come back. I'm sorry. Because here's how I want to do this. Again, this right here, the thing that we just found is m. Our equation would be y equals 8x. So what I can do is, especially for these tables, I can take my 2.5 or whatever number, I can take that 2.5 or that 3 or that 4.5 and plug it in right here for x and multiply it and see if I get the correct number. So I'm going to do this with my calculator real quick off to the side while I'm talking about it. Looking at answer choice B, I'm going to do 8 times 2.5 and I get 20. That one works so far. So now I'm going to, actually, let me write out these numbers so you can see what I'm talking about. I'm doing that times 8. Now I'm going to do 3 times 8. Well, that's 24. 4.5 times 8. I don't know that one off the top of my head. That one comes out to 36. I'm going to keep checking these. I'm going to do 8 times 5. Well, that's 40. Now I'm going to do 7.5 times 8. I'm willing to bet that's going to be 60, but let's check it anyways. Times 8. Yep, that comes out to 60. Our answer is definitely going to be B. And again, I'm using that because this is the slope that we found just a little while ago. I'm going to show you on C. Well, if I did 2.5 times 8, well, I'd get 20. If I do 3 times 8, I should get 24, but I get 22. So that one doesn't work. That's why C is out. This one right here, we said that she's making 8 pastries every hour, right? So here's what I'm going to do. I'm going to mark this. Here's our pastries. Paste sounds much tastier. Here are hours. Well, she should be able to do in 1 hour. We just said that she could make 8 pastries. Well, that's 7. That doesn't work. D is also out. So again, answer choice is B. All we did is we found out how many she could do in 1 hour. We took 20, divided it by 2.5. So we knew our equation was going to be y equals 8x. And we just plugged it into the table and figured out which one was going to work best for us. Number 4, plenty of fancy ways that we can do this one, but I'm going to tell you guys to keep doing all these the exact same dang way. So here's my recommendation. Take that 2 on answer choice A, and we're going to plug it in way the heck over here. And that y equals 3x plus 2. Well, if I do 3 times 2, I get 6, plus 2 more would be 8. So far, that works. So now I'm going to take the 3 right here. I'm going to take 3 and I'm going to plug it in over here for x. So I'm going to do 3 times 3. 3 times 3 is 9, plus 2 more, 9, 10, 11. That's 11. That one works so far. Now I'm going to take 4. Take my 4, plug it in way over here. 3 times 4 is 12, plus 2 more gave me 14. This is working out really well so far. We may have already found our answer. So now I'm going to take 5, take it over here. I'm going to plug it in for 3. 5 times 3 is 15, plus 2 more is 17. Heck, we already found our answer. Just to prove that this works or it doesn't work on the other ones, I'm going to take a look at B real quick. So I'm going to take my 1 right here. I'm going to come over here. I'm going to plug it in for x. 3 times 1 is 3, plus 1 would be 4, not 2. That one already doesn't work. Definitely not going to be B. I could do it on the other ones, but then this gets really colorful, and I want to make sure you guys can follow what I'm doing. So I'm going to move on to number 5 now. Number 5, Amy earns $300 each week in salary plus a 15% commission bonus on her total sales. If Amy wants to earn a total of $500 for the week, which equation can be used to represent this situation? Okay, no lie, hate this problem, like I do on a lot of these. Because we are talking about each week, and we're trying to figure out how much she's going to be making in 1 week, This each right here does not mean that $300 goes with an X. In fact, it doesn't go with an X because we're talking about a single week. So D is going to be out for us on this one. She's getting a 15% commission. Whenever we're talking about equations, we never leave this as a percent. We want to change this to 0.15. I've moved the decimal over 2 places. So if she's getting that commission, that's on each sale that she gets. So pretty much she gets her $300, plus she's getting a commission of 15%. A commission is when you make a little bit of money on whatever you have sold. Like if you sold a car or whatever else, it would be on however much you sold. So our answer choice ought to be pretty straightforward for us. It's going to be C. The reason A is wrong is because it's missing the decimal, so A would be out, and then B would be 85%. It's kind of the opposite of that 15% to make 100%. That would be if we were talking discounts or whatever else, but this one's a little more straightforward than that, so B is out. If you got questions on that one, I know that one can be very confusing. Please ask me because I need to know. I want to be able to explain stuff to you on that one. Pretty much, I mostly need you guys to remember this part here, right here. Make sure that you drop that percent, move the decimal over 2 places. Finally, getting to the easy scatter plots. So on number 6, it says, which scatter plot demonstrates a non-linear relationship? Okay, non-linear just means that it's not a line. So I'm going to look at these, figure out which one's not a line. Okay, well, that one makes a line, that one makes a line, that one makes a line. Well, that makes a big old U. So B does not make a line. Number 7 says, which scatter plot demonstrates a linear relationship? Okay, so which one is a line? Linear. Okay, so we got a little fancy arc thing here, fancier arc here, craziness there. Oh, look, D is a line. It's going to be D. Number 8, scatter plot below shows the cost in dollars of 5 different ladders. Each ladder is a different length. Based on the scatter plot, what is the cost of a 6-foot ladder? Okay, so here is I'm going to try to highlight this the best I can. This is clearly making a line, so I'm going to draw my line kind of through there. I'm guessing that's about where it's going to go. It's not perfect, but we'll take it. So it wants to know the cost for a 6-foot ladder. So here's my 6-foot ladder. If I go straight up, we hit right about here. So my cost looks like it's going to be, I don't know, the way I'm looking at this, probably a little over $60. Well, unfortunately, the only answer choice that we have that's anywhere close to it is $60. So the cost of a 6-foot ladder is got to be around $60. Number 9. It says Melissa collected data at a grocery store. She must be bored. She recorded how many people were in line in front of her and how long she had to wait in line. The graph below shows the data from several visits to the grocery store. Melissa went to the grocery store again yesterday. When she went to pay for her items, there were 10 people in line. Based on the scatter plot, how long would she most likely wait in line? All right, so we got 10 people in line. So here, looking at our numbers, well, there's 9, there's 10 people. So 10 is going to be a little bit off the graph. So 10 is going to be somewhere over here. I'm going to kind of make my own extra little set right here. And at this line, if it went a little bit farther, would probably cross somewhere in here. So it looks like our answer is going to be somewhere between, it's definitely going to be over 18. I'd say it's a little less than 20, probably 19. I don't know. So our answer, well, I'd said our answer is somewhere between 18 and 20. Well, 9 was clearly right there at 18. I think our answer is going to be more than that. And actually looking at these, our line jumps up perfectly every time. So my dot was off. Our answer is going to be 20 on this one. So she can expect to wait about 20 minutes. All right, on to number 10. Data in the table below represents a linear relationship. Which equation can be used to describe the relationship between x and y shown in the table? So here's what I'm going to do. What I've been freaking doing, because I think it's the easiest way to go at it. One thing I do want you to remember, though, wherever x is 0, this is our y-intercept. Or B. So our equation has to end with -2. So that means that A is going to be out and C is going to be out. So I just got to figure out what my slope is. I could do change of y over change of x. That absolutely works. But a lot of you guys are struggling with that still. If you're good at it, go for it. Otherwise, plug stuff in and see which one works. So what I'm going to do is I'm going to take, let's start with this 2 right here. I'm going to take 2. I'm going to plug it in here for this x. If I did 4 times 2, I would have 8. 8 minus 2 would be 6. That one doesn't work because we got 8 here. B is out. So now I'm going to go ahead and double check this. We're going to change this 2. I'm going to take this 2 and I'm going to plug it in here for this x. Well, I do 2 times 5, that's 10. 10 minus 2 is 8. That one works. I'm going to check a couple more. Now I'm going to take 3. I'm going to plug it in right here. 5 times 3 is 15. Minus 2 more would be 13. This one works. That's pretty much our answer. But I'm going to check one more just to be on the safe side. I'm going to take 5. I'm going to plug it in right here. 5 times 5 would be 25. When I subtract 2, I get 23. D is absolutely going to be the right answer. I could go through and check the negatives, but nobody likes negatives, so I'm not going to bother. Number 11. Line Z has a slope of 4.5 and goes through point 213. Which equation best represents line Z? Well, our slope, that's our M, so our answer has to have an M of 4.5. C is out, D is out. So we've already got it narrowed down. What I want you guys to remember is that these are x, y pairs right here. So here's what I'm going to do. I'm going to take my x, I'm going to take this one right here, and I'm going to plug it in right there and see if I get 13 back out as my answer. So I'm going to do 4.5 times 2. 4.5 times 2 is 9, and then 9 plus 4 is 13. That's going to be our answer choice right there. I'm going to I want to write this one out for my folks that aren't listening, because I know there's somebody out there crazy enough to not listen to my luscious voice. So whenever I multiply these two, I get 9, and then 9 plus 4 equals 13. The 13 that was right there, which I'm not sure why I'm saying this again, because that was for the people that weren't listening in the first place. Okay, number 12. A scatter plot of data set is shown below. Which statement best describes the trend of the data set? Well, just looking at it, it's all over the place. Like, it makes no sense. It wouldn't be useful. This would be like comparing your grade to your height or your shoe size. There's no relationship there. So, data has a positive trend? Nope, there's no trend at all. The data the data set has no trend or no association. That is absolutely what we're talking about. These others suggest that there's some kind of trend, even a non-linear trend, meaning that it makes some kind of arc or some kind of check or something. That just indicates that there's a trend. It's not even non-linear. There's no trend whatsoever on this graph. Number 13. 3 athletes each plotted their energy levels throughout the course of the day on graphs as shown below. Which conclusion best supports the data plotted by these athletes? Okay, before I even bother reading these, let's check out the graph. So I would assume that this is going to be, AM, we'll call this PM, and then these will be energy levels. So energy, except I can't spell energy, and I didn't mean to do all that stuff that just appeared on there. Okay, let me try this again. Energy, energy. Sure, that's how you spell energy, I think. So, not much energy in the morning, lots in the afternoon, and then it goes back down. Looks like that's about the same for all these guys. Hardly energy in the morning, lots in the afternoon, and then it takes a dive down. This is about how my day goes. Hardly energy in the morning, drink some coffee, I survive most of the day, and then I get home and crash. All right, so which conclusion best supports the data plotted by the athletes? A, the athlete's energy appears to have a nonlinear association. This is true, because it's not linear. There's definitely an arc there. And increase until the middle of the day and then decrease afterwards. That sounds really dang good. That's what we were just talking about. B, the athlete's energy appeared to have no association. Now there's clearly some kind of association there, so B is out. C, the athlete's energy levels appear to have a negative linear association. Again, we just said it's not linear. They make an arc. D, the athlete's energy levels appear to have a positive linear. No, that's not true, because it goes up and then it goes down. So our answer is definitely going to be A on number 13. Final one. So this is supposed to be Carly's progress from a 5-kilometer race is displayed in the following graph. Based on the scatter plot, which statement is a valid conclusion? I'm going to draw my own conclusion first before I even bother reading those. All right, so the distance, well, it looks like as time goes by, she goes farther in the race. Duh. All right, so let's go ahead and read these. A, as the number of minutes Carly spends running the race increases, the distance she runs per minute increases. Here's the problem with this. Yes, the distance increases, but the distance she runs per minute, that's saying that she gets faster every minute. Every time she runs, she gets faster and faster and faster. No, that's not at all what is happening. This per minute is screwing this whole thing up. She doesn't get faster as the race goes. She just goes farther as the race goes. B, the number of minutes Carly spends running decreases. The distance she runs per minute decreases. That's No, that's just dumb. That doesn't even make sense. C. As the number of minutes Carly spends running increases, the distance she runs increases. Well, duh. That's what we said at the beginning, just with no fancy trip ups like that per minute junk. The answer is definitely going to be C on that one. Guys, if you have questions on these, please ask. Please review, and I hope that you've been taking notes on a blank sheet of paper in your handwriting, not copied from somebody else, and not run through a copier or off of a printer, not typed. Got to be handwritten, so you can use these on the test that comes up. Good luck on that, guys.